Hi, welcome to part 2 of our workshop series on COVID-19 data analytics with Kubernetes. My name is Haghighi and I'm a developer advocate with IBM. This is a multi-part workshop series on building, deploying and managing microservices applications with Kubernetes and Openshift. This lab is dedicated to getting started with containers and Docker as a fundamental requirement for our future labs. If you have watched part 1, you already have some background about our application, microservices architecture, and what we are going to achieve together through these workshops. In this lab, you will learn about containers, the basics of containerizing microservices with Docker, how to run and connect Docker containers, and best practices for building Docker images based on your application services requirements. And here's a quick look at what you're going to learn throughout this workshop series and how Docker fits into our learning journey as a prereq for diving deep into Kubernetes and Openshift. In this lab, we'll containerize our applications microservices with Docker, and in the next lab, we'll deploy and manage them with Kubernetes. Later, we will use Openshift to automate the entire process of containerizing, deployment, scaling, and management with a few clicks from the Openshift web console. So let's get to our application. As you may have seen in the previous lab, our workshops are designed around an application that combines multiple containerized microservices for parsing and displaying COVID-19 time series data for the number of positive cases and mortality rates in different countries and regions. At the beginning of every part, we take a quick look at our application with respect to the primary topic of that section. This is to showcase the end result of what we will learn together in that part. And as you will see shortly, I've got my application, which is like 3 Java microservices already running in the background, and we'll go through them together. Before we view the application, here's a quick summary of the architecture and the components. Our application has been designed and developed in Java and Spring Boot framework. It provides us with a number of API endpoints for retrieving COVID-19 data per region, country, dates and periods. It comes with a number of containerized microservices, including a data parser for positive and another data parser for mortality rates per country, and a user interface for displaying data and invoking those APIs through a number of sample functions. Data is fetched from Johns Hopkins University's repo, which is an authentic source of COVID-19 data, and then stored in our local data repository, or JPA, as we will go through that later. Here's a list of sample API endpoints, as we will test them out shortly. Both applications are fully open source and can be accessed with full instructions on my Git repos. Just in case you have forgotten about those topics that we reviewed in the previous lab, here's a quick flashback from our previous lab on microservices. So basically, microservices architecture addresses all of the liabilities that are inherent in monolithic applications. Microservices architecture allows different parts of our application to evolve on different timelines. They can be deployed separately, and you can choose your technology stack for each microservice as it basically best fits the purpose. And also you can scale your individual services dynamically at runtime, or let's say you can create instances of each individual service. And obviously that brings us to the most crucial quality or of the feature of microservices, which is if a single service basically fails, our application is still going to be up and running, and it wouldn't necessarily become unavailable and unresponsive to customers. And that the reason for that is because they are designed, they're not designed and operated as a single entity like in monolithic architecture. As you saw in the previous lab, we broke down our application into several microservices based on their functionalities and the purposes they fulfill. And in this lab, we will containerize them with Docker and use Docker to run them. Therefore, we convert our monolithic application into a multi-container application. If you want to review how this application has been designed and how microservices architecture optimized it, please refer to the previous workshop so you get full details of how these components are going to interact. You may ask, why Docker? So I would say, modern application development and app modernization techniques consist of 3 important stages of build, deploy, and manage. Docker plays a vital role in the build stage, and even partially the deployment phase. As you can see from this slide, 4 stages we are going to follow in this workshop series. Docker is responsible for almost all initial steps. And then, we get to the next part, which is what is a container? Because in the previous slide, as you can see, we are basically talking about containerization, and Docker is responsible for that. So what is a container? A container is a unit of software with the application code packaged with its libraries and dependencies so that it can be run anywhere. If you're familiar with virtual machines, the first question you may have will be, what are the differences between virtual machines and containers? Well, first we need to know that what virtualization is. Basically, virtualization is a process to create an abstraction layer over computer hardware that allows the hardware elements of a single computer to be divided into multiple virtual computers or virtual machines with the operating system in each VM. VMs have been around for quite a while and are considered the foundation of first generation of cloud computing, and in fact containers are inspired by the VMs. Containers virtualize the operating system, so each individual container contains only the application, its libraries and dependencies, instead of virtualizing the hardware. So it basically virtualizes the operating system. And basically, containers are a lighter weight, or a more agile way of handling virtualization. So rather than spinning up an entire virtual machine, a container packages together everything needed to run your app except the operating system. And in case of Docker, this so-called visualization of the operating system takes place by Docker, and that difference alone makes a huge difference when it comes to handling, transferring and loading containers. So containers have been around for quite some time, and developers can create containers without Docker, but Docker makes it easier, simpler and safer to build, deploy and manage containers. And Docker is essentially the first toolkit that, due to its simplicity, enabled all developers to build, deploy, run, update and stop containers using simple commands and work-saving automations. So that is an important difference between the technology and the toolkit, between Docker and containerization. The other important difference is between containers and container image. That the other important difference is the difference between another aspect is the difference between a container and Another aspect is the difference between a container and a container image. A container image is only a package of code, libraries and dependencies, like a tar file, and it only becomes container at runtime. So container images become containers at runtime. So container image is not the same as a container, so make sure you don't use them synonymously or mix them up. We've got a number of prereqs that you need to download and install, as we saw in the previous lab. So you need to have the version 11 of JDK on your machine. You need to install Docker, and you need to have Minikube as well for the next lab. But if you install Minikube for this lab, that would basically makes it easier for you to use the Docker daemon within Minikube to containerize your application. So the first step is to go ahead and clone the GitHub repositories that I've got it here for both applications. I've already cloned the repos, so I've got it all here for both applications. Go ahead and browse into your first application, the parser. As you can see, we've got a target folder. In the target folder, we've got a jar file. So once we package it, we're going to go ahead and run the jar file to test our application. So now what you need to put is mvnw clean install, and that basically packages your application. Maven basically packages your application. mvnw clean install. It's going to take a little bit of time. I'm going to go ahead and package my UI as well. So whilst the other one has been completed, I'm going to go ahead. I'm going ahead and making this happen as well. It's going to get compiled and built. Seeing the screen splash, so that means it's done successfully. Let's wait for this. So just for you to know that the UI is running on port 8082, 8081, and our parser is running on port 8082. Since my UI is ready, I'm gonna go ahead and load it on my browser. Okay, so my other application is also compiled and built, packaged. So let's go ahead. If you remember, this was the UI that we opened from the previous part. So I'm going to go ahead and host port 8081. So this is our UI. Oh, we're not running it yet. So now my both applications have completed compiling and building and packaging. So my both applications are now compiled. So what I'm going to do now, I'm going to go ahead and run them. So the way you can do it is if you basically so now my both applications are built. So what I'm going to do is I'm going to run them and test them through the CLI and see if they run successfully. So you've got to basically go into your targets folder, and then from there you have to say Java jar and then your jar file. So I'm just going to use a wildcard because there's only one jar file in that folder. I'll do the same thing here. CPU target, and then let's take a look at the jar file just for your information. Here's the jar file, the snapshot.jar, like COVID-19 snapshot.jar. So Java jar. You can I can just put the name fully for you if you want. So this is a jar file, so we can just put the full name. And this is going to run as well, and then I'm going to go ahead and test it out on the CLI and also in the browser. So our UI application here is running on port 8081. So if I browse to port 8081, localhost 8081, here's my application, here's my UI, and now I can basically go ahead and connect to my data parser. So the way we're going to do it, just going to see if it's ready. So the other application, the data parser, is running on port 8082, as I said. So I'm going to go ahead and connect to port 8082. It's not ready yet, so this is still working on the database. It takes a little bit of time. As you can see, it is initiating the JPA Entity Manager factory. Okay, so my application started. So if I go back to my browser, now say connect, it's going to go ahead and connect to my parser. As you can see, the data is going to be available here. Let's just look at a country, for example. Let's look at Germany. This is the data, the death rate for Germany, as you can see here. So for the 6th of July, we've got 9,022. So this is working in our browser. We can go back to our terminal and just ping our application just to see it's available. That's 8082. And hello world. And if I show data and then Germany, that's the data for Germany. As you can see again, 6th of July, we've got 9,020, and here's the full data set. So our application, our Java application, is running successfully. So I'm going to go ahead and stop them. Control C. So our Java files are going to stop. And let's clear our screen and go back to our slides. So that was the first part. So we basically downloaded our Spring Boot application, we packaged it and ran the Java, the jar file. The first step to build our image with Docker, as you understand, as we had described, we need to have our Docker image first, and then once our Docker image runs within Docker, on top of Docker, then they become containers. So the first step is to create our Docker image, and we need Docker file for that. There's some syntaxes that we need to use for that. First one is obviously always from, and that defines what image to base this off of. So we say like JDK 11 or Linux or Ubuntu. It depends on your application. So you can decide what this image is going to be based on, and then the variables before this image is built. So that's arg. The difference between arg and env is the fact that arg is the variables that needed before the image is built, whereas env are variables that are going to be available after the image is built. Then we need to copy new files and or directories from our source and add them to the file system of the container. So we use copy for that. Add kind of does the same thing. Entry point basically configures our container to run as an executable, and then run basically defines what runs basically within our container at build time. So as you can see here, I'm going to go ahead into our parser application. So I've got my Docker file there. So let's take a look at our Docker file. So I've got my from is adopt OpenJDK, OpenJDK 11, the latest version. That's what this image is going to be based on. And then the next part is what are the args, basically those environmental variables before the image is built. Jar file is going to be located in my target folder, target directory. So that's basically what I need for this particular bit, and that's why we get JDK, and then we look for our jar file. And then I'm going to copy that jar file that we just set here as the our parameter, and copy it as app.jar. So that's how it's going to be known. And then the entry point basically defines how to run this and make this executable. As you had seen previously, I ran it by just putting in java -jar and then app.jar, which is the name of our jar file now. So this is our Docker file that we need to run a Java application. Let's close this. To build our image, Docker build -t image name and the path where this Docker file is located. So let's go ahead, Docker build t, I'm gonna call it my app v3, and then present directory. So it's going to go ahead and create my image, Docker image. I'll do the same thing for my UI app. So as you can see, I've got the Docker file here, and it is exactly the same because both of them are Java applications based on OpenJDK 11. So I'm going to say Docker build t, and then my app UI, and this is going to be version 3 in the present directory. So it's going to go ahead and build my Docker image for my UI. So what we need next is we're going to basically just see the Docker images available now on our machine, and also we're going to take a look at the Docker processes running in the background. Obviously we are not running any Docker containers, so there's nothing there at the moment. So let's take a look at Docker images. So these are the images I've got available in my repository. As you can see, like in we've got my app UI version 2, version 3. Version 3 is the one that I've just created 8 minutes ago. The other one also was a test I ran before I started recording this video. I just wanted to make sure everything goes through. And then I've got my UI, my UI app. So my app UI are the ones that we've created, and then the other one is my app version 3, which was 9 minutes ago. That was our parser application. But if you look for Docker PS, any processes running at the moment, there's no containers at the moment running. So you can basically take a look at what containers are running by Docker PS. If I look for Docker PS all, I'm going to see all the processes and even the ones which are stopped. So I've got UIAP.jar, which was like 2 days ago, and it was basically stopped. So Now let's go ahead and run our Docker. So this is a greater step. So we've created our Docker image, and now we're going to run it. So once we run it, then it becomes a container, as we had previously looked at. So the instruction for that is docker run. You can define your port. So what is the port on the host side and what is the port on the container side? As you had seen when we tested the jar file, we've got one for the parser on 8082 and for the UI on 8081. I'm going to basically assign the same ports to both container and the host. So on the host side, and my local machine is going to be exactly the same port. And then you need to put your image name and whether you want it to be detached, and if you've got the same application running with the same name, basically going to remove that and replace it with a new one. And the detach, basically the -d defines whether you want it to run the image in the background. So let's go ahead and run our Docker image. Docker run p, I'm going to say 8082, then 8082. So the first one is our host and second one is our container. The container, the image name is going to be the one that we've just created, so it's going to be my app v3. App v3, and that's all we need. 8082. Let's run it. So as you can see, the Java application is coming up, even though it is containerized and it is now a container, but the same processes, the same sort of outputs, you can see that happening. There was a way for us to stop this from happening, was just like by including an ampersand in our environmental parameters, so the Java application would have run in the background. I'm going to go ahead and also run my UI application. So I would say docker run p. For this one is 8081 and then the jar name, the image name is going to be my app UI v3. 8081, that's right. So now it's going to go ahead and start the container. So both of these applications are now containerized and running as containers. So I can just easily move it into a cloud platform without any problem, or just migrate it into another machine as long as Docker is available on the other machine. These applications, with all their dependencies and libraries, are gonna basically run as containers on those machines. Let's test it out properly, see what it's like. So 8081 still available. If you go on 8082, hello world. So both of these containers are running. This is interesting, but I'm not going to basically do any data processing with this, and the reason for that is because if I try to connect, even though you've seen my 8082 is available, if I try to connect to 8082, server not responding. What is the reason? Even though I can access it from here, because this is a Java file in my container basically running, it works fine. You can see all the data is here. I can easily, this is my HAL browser, so this is just for demonstration purposes. You can easily just go ahead and explore different parts. Like if I say hello, you can say, so hello world comes back on. If I say get country data, Germany, all that data is going to come back. You see, this is my data being available, but when I try to access it from my UI, it doesn't work. this is interesting. So I'm going to show you why this is actually happening. So that we encountered a very interesting problem, and we're going to learn a lot from that particular problem. So we managed to communicate with our containers. So through the browser we opened the UI, or also we communicated with our parser. But when we tried to communicate with one container through another container, which was kind of our UI discovering data or retrieving data from our parser, that didn't work, even though both containers are running. Let's go back here and say docker ps. As you can see now, both containers are running. If I try to ping my containers as we had tried from the browser, localhost 8082, hello world. So it works, it is available, and as you had seen here, my UI is also running. What is the problem that we can't connect from here to port 8082? We need to first of all stop our containers, but before we do that, to solve this problem of us discovering our containers, communicating with our containers, but containers not being able to communicate with each other, we need to run a quick test. Let's SSH into our UI, and then from our UI try to communicate with our data parser. See if that works. Maybe we are not following the right port number or something like that. So what I'm going to do is I'm going to use docker exec to communicate, to SSH into my UI. To do that, I'm going to say docker exec IT, and dash IT means interactive way, and then I'm going to use my container ID, or you can use the container names that in this case is compassionate Heisenberg, which is a random name that Docker basically assigns to containers. And then bin bash. So we need to go to bash basically within our container. So we are now inside our container, UI container. So I'm going to go ahead and ping my parser, see if this time we get any responses back. Yep, failed to connect. So as you have seen, this doesn't work. Containers cannot discover each other within Docker machine. So the problem is that our Docker containers need to belong to the same network in order to be able to communicate with each other. So here we are going to create a network and associate our containers with those networks. So the way we do that is docker network create, docker network create, I'm going to call it test, my test, net, or let's call it my net. So now my network is created. So what you need to do next is take a look at this network, inspect docker inspect network mynet. So there's some information about this network, such as subnets and the gateway, as you can see here, and also what the network is called, the ID for that network, as you can see is the same thing that was returned, basically same ID that was retained after we created the network. Driver is important, that's a bridge, so this network is going to work like a bridge, and that's it. So once we have the network and we inspected that the network is healthy, let's stop our containers. So docker ps, so we've got these two containers running, docker stop container ID. So that container is stopped. Let's stop the next one. Let's call it the parser. So the other one is also stopped, as you can see here. So what I'm going to do, I'm going to run the containers again, this time with a new flag. Basically it's going to call net, so --net. So let's go back to our containers before. Yeah, when we run our containers, so I'm going to call it net and then my net. See, it's quite simple. The same thing, but we basically attach it to a network. Now it's going to go ahead and start running. Net, my net. So our parser and our UI are now running. Containers are running with attached to a new network called mynet. So next step is for us to basically inspect we've already inspected the network. So this one is going to call mynet in this case, and then we're going to basically try to SSH into our container again and see how we can actually discover, if we can discover the other container from there as well. So let's go ahead and SSH into exec. So I need the new IDs for my containers. So these are the ID numbers for containers. So I'm going to say docker exec it, and I'm going to use the UI here, and it's going to be bin bash. Okay, so I'm now inside my UI. So let's call our friend the parser and see if we can talk to the parser. 8082. Hello. Failed to connect. Localhost 8082. Hello. Ooh. So the problem here is that now we need to use a new IP address. We can't just go ahead and use localhost. We need to use the IP address for that container. So what we say is we need to inspect docker inspect network and then mynet. Network mynet. Oh, we are inside the we have SSH into the container, so we need to exit that first. Say docker inspect mynet network mynet. Okay, so there's a gateway here and there's subnets as well, and now we need to look at our containers. So let's say inspect my. I'm going to first give the IDs again. Inspect UI. See what sort of information we get here. So there's an IP address here. The gateway is the same gateway as we saw for our network, and the IP address is 03. If we go ahead and look for our parser, so this is the IP address for our parser, and say docker inspect. So this is the IP address 1702. So that's the IP address that we need to use to communicate with that. So if I go ahead again, exec, docker, so that was 1702. Yes. So I'm going to go ahead and SSH into my Docker container again. Exec it. Okay, I'm inside cur 172.0.2. What's the IP address? 17.02.02, and then 80.82. Hello world. Okay, so what happened? So we basically connected our Docker containers together, and now we managed to communicate with our containers from one container by SSHing into one container and communicate with another one. And if you inspect the containers, then you can see that they belong to the same gateway. So we have just discovered how we can actually connect our Docker containers together on a machine. But obviously, going ahead, we are going to use Kubernetes, and we're going to have a Kubernetes cluster that would basically resolve that problem for us, so we don't need to do that. And our pods and nodes are going to connect, are going to basically provide us with enough services to connect our containers and our applications together so they can discover each other. So going ahead, one problem we're going to look at is given that we've basically created our Docker, how is that going to be, Docker image basically, how is that going to be discovered or pushed into Kubernetes cluster, because that is basically at the moment on our machine. So this is a classical problem that you deal with even when you're basically developing for public cloud, other public clouds. You know, for instance, for IBM Cloud, you've got a IBM Cloud Container Registry, so you need to push your image into the container registry, and then from there you can basically pull it or push it into your Kubernetes services or Openshift, and that's the way it works. So every cloud provider provides their own, offers their own container registry. The one with IBM is ICR, IBM Container Registry, and all your images you can basically just push it there. One way we're going to basically look at it is, first of all, we want to switch to our Minikube or Kubernetes Docker daemon rather than just doing everything on our own machine. So by running this command eval, basically we are changing our environmental parameters to use the Docker daemon inside Minikube as our Docker environment on our own machine. So if I go ahead, let me clear everything. So I've got my Dockers here. So let me just stop my Docker images, my Docker containers. So Docker PS, Docker stop, and the other one as well. Okay, so both containers are now stopped. Clear, and this one as well. Okay, so what we're going to do now, we are going to switch to our Minikube or Kubernetes daemon. And if you want to switch back again to your own Docker daemon on your Docker machine on your machine, you have to put a -u after Docker end. Okay, so I need to run my Minikube first. Minikube start. So if you haven't got your Minikube started already, go ahead and start your Minikube, because that is the required part. In the prereq section, I give you a link on how to install Minikube on your own machine. It is a very quick process, less than 5 minutes. Basically, you can have your Kubernetes cluster running on your own machine. So my Kubernetes is running with Hyperkit VM. And one thing we're going to look at is, obviously we're not going to run any Docker container because we've seen the classical problem. So what we're going to do is we're going to use the Docker daemon just to push our image to build our image, and then later on push it into IBM Cloud Container Registry. So it's going to take a bit of time. Okay, now it's done. So let me go ahead, and now we are basically using the Minicube's Docker daemon. So I can basically go ahead and build the images that I built before, but this time with Docker daemon within Minicube. Build. So even if I try to look for Docker images, now you're going to see like a new list of images, because these are not the ones on my machine. These are the ones within your Kubernetes cluster. If I say Docker PS, obviously these are the processes already running within Minicube. So this is different from the one that we are dealing with at the moment. So if I say Docker, let's go back to our command where we ran Docker. We don't need to use mynet anymore, because we don't want to attach it to any network. So now if I build my image, which was here, this is now going to be done by the Minicube Docker daemon. Successfully tagged. Let's look at it now. For this as well. So Docker build UI retrieve. So here, when I search for Docker images, there was nothing about our apps that we had created. There's one called V1, which is an old one from before. But if I do it again, Docker images, now you should see them, but you didn't see them. Interesting. Docker images. Oh, my other environments are still on the previous one, so I need to refresh, because it is still on the previous profile. So you need to copy paste our Docker here. So I'm going to go to COVID-19 and going to go to so now let's create our Docker. Done. Let's look at the Docker images. Yes, my app v3 now is there. So we can do the same thing for, just push this back down. We can do the same thing for this app. Just been lazy, not gonna type it again. So let's go back, cd COVID UI tree. So it's gonna go ahead again, build my Docker image. Successfully done. Docker images. Now my UI v3 and my app v3 are there. 4 seconds ago, 40 seconds ago. Okay, so our Docker images are now inside Minicube, inside our Kubernetes cluster. We don't want to run them, obviously, and the reason for that is what we went through. There's a proper way of doing that, and we're going to basically go through that in the next lab, which is creating pods, creating deployments, and putting our microservices as containers within each one of those pods. So now, basically, our Kubernetes cluster, as you have seen, is capable of discovering all those images, and we can basically go ahead and even run those images, but again, it wouldn't be possible for us to communicate with them normally. There are ways to do that, obviously, but this is the subject and the topic for our next lab that we're going to basically deploy the applications. First of all, push the container images into IBM Container Registry, and then run them, deploy them onto Kubernetes. So in this lab, what we learned about Dockerify, how to build Docker images, difference between Docker images and containers, even though I mix them up quite often when I'm describing things. how to run Docker containers, use Kubernetes Docker daemon as we've seen just now, and the Docker registry on your own machine and Docker registry within Kubernetes cluster, and how to connect, how to SSH into Docker images. We looked at that as well, and also connecting Docker containers, how to do that, which was through the network, and also how you can inspect your Docker containers and your Docker networks. So you've finished the Docker section, so you've successfully containerized your application. In the next bit, we are going to look at Kubernetes, how to deploy your application on Kubernetes. Thanks so much for joining this lab. Stay tuned. I'll see you